So this is 1993, number 32. So back in chapter 3, we took the derivative of arc sine of x, and we end up with that. And so we look at this and say, man, that is so close. If that 4 were a 1, this would be wonderful. So then we do some algebra and realize I can factor a 4 out of there. And somebody might say, you know what? I don't see a 4 here. But there actually is a 4 there. It's invisible. It's actually 4 over 4. So if you take a 4 out, you're left with a 4 on the bottom. And we can double check that, distribute this, and it comes out to be our original. And then we recognize the square root of 4 is 2. And so I claim this is equivalent to that, just by doing some algebra. So now I rewrite my original problem with my new bottom part. And then the 2 is a constant, so I can factor that out in front, or pull that out in front, I should say. Now, this is almost perfect like that, except that's not a single variable. It's a function, x over 2. So I'm going to use sub and replace that with u, so then I have a single variable there. So we're going to let u be x over 2, making du 1/2 dx. And here's the pretty part. 1/2 dx, look at that. We already have 1/2 dx. So all that becomes du. And now I can rewrite this as du over 1 minus u squared square root. Oh, I forgot my square root. But 0 and radical 3 are values of x. Because we have a dx, I know they're x's. This is wanting a u. So if I put 0 in for x, that's going to be 0 over 2 or 0. So u will be 0. If I put radical 3 in for x, I get radical 3 over 2. So that becomes that value. Well, the antiderivative of that is arc sine. And then using the fundamental theorem, I plug in radical 3 over 2. I plug in 0. And what is this saying? This is asking what angle has a sine of radical 3 over 2. And I know that's pi over 3 because I know my unit circle. It's asking what angle has a sine of 0. And I know 0 has a sine of 0. So the answer will be pi over 3.